Hello, this is segment 2 of the AQA GCSE Physics. It is on Forces and Motion by Joe Bailey Revision. So let us begin. So there are two different types of forces. Scalar forces, which have a mass, distance, speed, energy, which include mass, distance, speed, energy and time, and vector quantities, which include acceleration, displacement, velocity, and force. Basically, the difference is vector quantities include a direction, but scalar quantities only have size without direction. So, basically, the magnitude is the amount or length in one direction. So, that doesn't apply to scalar as there is no direction. So, what is the resultant force? So, a resultant force is the effect of all the forces combined. So, on this diagram, we can see that there's 3n going that way, 4n going the same way, and 5n and 6n going that way. So, if we add those two together, we get 11n, and we add those two together, we get 7n. So, we have to minus the biggest from the smallest to find out how many is going in the biggest direction. So, in this case, it's 4 newtons. So, this is called resulting forces. And it's where you use one force to find the two that are contributing to it. So from this line, which has 100 newtons on, we can find out that it's going 10 centimetres, as that's there, and, so the line there is 10 centimetres, which is 100 newtons. Which means that the fact that you draw the lines from the end, and the fact that this line goes up to 8.3 centimetres means that it's 83 newtons. The fact that that goes to 5.7 centimetres means it's 57 newtons. So basically, from that one force, you've managed to find the other two. So again, velocity is speed with direction, and speed is how fast and there's no direction. Which means that speed is a scalar, and velocity is a vector. Displacement is a vector. It's how far you are from a point. It can be positive or negative. Whereas distance is how far you've gone, and it's scalar, and it can't be negative. Because if you go back, you're still going somewhere. You're not taking into account the direction. So another way we can split forces is into contact forces and non-contact forces. Contact forces occasionally send you emails with promotion. Wrong script. Contact forces actually touch things physically. So that includes air resistance, reaction, tension, and friction. And some non-contact forces, which don't touch anything but still are forces, are gravitational forces, magnetic forces, and electrostatic forces. Because if you think of gravity, gravity isn't actually pulling you down, it's just its effect. Same with magnets. They attract together, but they don't need to touch to attract together, because that would take away the entire point in it. So, now on to everyone's favourite category, the equations. So, let's start with this side. So, work done. So, work done, which is basically energy in joules, equals force times distance. Which basically means that 1 joule of energy is transferred if 1 newton pushes an object a distance of 1 meters. So basically, those two times together makes up that. You can also rearrange it, so force would equal work done divided by distance, and distance would equal work done divided by force. Which means that 4 joules would be transferred if, say, 2 newtons pushes an object a distance of 2 meters. Because that's them two twos times together to make a 4. That's an example of using it. So, weight in newtons equals mass in kilograms times by gravity. And gravity on Earth is 10 newtons a kilogram. You will probably need that. Basically, something I've drawn up here is the fact that weight uses newtons, and force also uses newtons. That's because weight is a force. So you could use weight, you could substitute it into that equation as force, and then use it to find the work done if you have the distance. Basically, weight is mass taking into account the effect of gravity, which is why they are times together. Because, say, we weren't on our planet, then we would go off our mass, but the fact we're on our planet means that so much is added because of the power of gravity to our weight, to make our weight from our mass. So yeah, you basically times them two together. So say we're on Earth, 10 newtons. Say the mass was 5 kilograms, you do 5 times 10, which equals 50, so the weight would be 50 newtons. Well, this is probably the most common equation out there. Speed equals distance over time. Speed is in meters a second, distance is in meters, and time is in seconds. You can remember this easily because the meters a second means how many meters per second. If you're trying to find something per something, you divide it. As you're trying to find out how much distance is travelled for 1 second, so you divide it by the total amount of seconds. Just a cool edgy title there, forces in motion. So what was the next bit? Acceleration. So acceleration in meters a second squared equals change in velocity in meters a second over time in seconds. You can see that it's meters a second squared as you're squaring the seconds, as that is basically what's happening. You're adding an extra second to it. And basically how you find the change in velocity is the final velocity minus the initial velocity. So another way of writing out the equation would be acceleration equals v, which is final velocity, minus u, which is initial velocity, divided by t, which equals time. Always remember that equations such as this say this has got time in. Speed equals distance over time also has time in, so sometimes there's multiple mark questions where you have to use one equation and then use another equation and substitute it into the entire thing. I remember there was a question like that before. I think it was on gravitational potential and then something like that, but yeah. So velocity time graphs. So on a velocity time graph, the gradient shows the acceleration, and the area underneath the graph, I believe, shows the distance travelled. So another important thing about velocity is terminal velocity. So that's when all forces are balanced. So when all forces on an object are balanced, it either does nothing or the speed becomes constant until forces change. So, for example, when a parachuter is parachuting, when the parachute is open, the forces change again to add more air resistance due to the increased surface area. Yes, just checked it and I'm right. So, terminal velocity. This idea is Newton's first law, that if all forces are balanced, either the object stays at rest or the speed becomes constant of it continuing moving. So yeah, that's all the equations I think you'll need, and that's the last bit there. So yeah, I'm just gonna leave this quickly. I mean, it's called forces of motion, not forces in emotion. So goodbye.